Chapter 11 is the last chapter we're going to do this semester, so I hope that you are excited about that. Thank you for making it this far. Thank you for all the time and effort that you've gone through to get here, and I'm happy to be done with the videos for this semester. So, Chapter 11 is about linear regression. And you will kind of know what's going on in linear regression. You've seen these pictures before. It's where you have some dots, and then you have a line kind of going through the middle of the dots trying to approximate them. That's what we're trying to do here. So we're trying to describe this process and think about what's going on. But what really is happening in a linear regression is when you have two variables, and we're trying to talk about the relationship between them. So we're really talking about a relationship between two variables. And so in the case of a linear regression, it means it's a linear relationship. And what linear means is when one increases, the other increases by some fixed amount. So if your x increases by 1, then your y increases by 2, and that's a linear relationship. And relationships are when we have two variables, one that's kind of relating to or affecting the outcomes in the other variable. Let's think of some good examples of this. Well, one is if you have a business, then maybe the amount you spend on advertising should have a relationship with the amount of revenue you have. So if you spend more in advertising, you should make more in revenue. So we would hope that it would have some sort of relationship there. But there could be some other relationships that you can have, and there's all sorts of things that can be connected or interconnected to you. We also would expect the price that you spend would also have a relationship with the number of items you sell. So you'd expect the price that you sell it for, the number of items, to decrease the larger the price. You'd expect that to also have a relationship. So these are the types of problems that we're talking about in this section. And in this section, your textbook always talks about the relationship between these two items using an equation. The equation they write is y equals b naught hat plus, or beta naught plus beta 1 hat x plus epsilon. And first, let me apologize. These letters are just like a jumbled mess. I don't know why they picked those letters other than other letters. But what you should really think of when you see this is your classic line, y equals mx plus b, except notice that the m is your slope, and so for us the slope is always that term that goes before the x. So whatever your term is before the x, that's your slope, and then your b is your y-intercept, and that's the term that doesn't have an x on it, and that's your b. And then there's one more term that shows up that your book likes to talk about, and it's this epsilon term, and this is what we call the error. And that's because for a line, there's a perfect relationship between x and y, and for our equations, there's not. So we know that the amount if you increase ad revenue, you also increase your total sales, but we wouldn't expect it to be perfect. So if you double ad revenue, are you going to double sales? Well, you might not. There's a little bit of error. So sometimes you get a bigger bump, sometimes you get a lower bump, and that's due to randomness, just with whatever's happening when you're shopping. So maybe your ads were great, but then the coronavirus hit, and so that changes all your sales. Okay, so there's this error term that has to do with randomness that happens in life. Well, what we're going to do when we go through this section is, and by the way, we call this the deterministic part, and this would be the random error part. But okay, what we're going to do when we go through this section is we're going to talk a little bit about how to think about these things, and then I'm going to go to another video where I tell you how to calculate these using your computer, and I'm going to do 3 different videos, and so you'll choose the one that kind of fits you the best. And then finally, we'll come and talk a little bit more about how to think about a coefficient of correlation and what that means. So we'll have a bunch of different videos all connecting things together. But in the end, we'll hopefully really understand Chapter 11. We'll understand this idea of linear regression. So let's go to our first problem. Our first problem is this problem that you all can see on page 47, and it's where we have this person on a diet, and let me write those down, how this person's doing on their diet. So this person on a diet, we have their days that they're on their diet and their weight. And so we have 1, 2, 3, 4, 5, 6 of these. So I've got to write all these down. I should have written these down before I started. Sorry for my slowness here. We've got 0, 5, 7, 12, 19, and 28. And then we've got 252, 249, 250, 247, 246, and 244. Okay, so here's all the numbers that I had on our table. And now our first goal is to create a scatter plot. And what is a scatter plot? Well, all a scatter plot is just taking all these numbers and just putting them on an XY axis where this is X and this is Y. And so what we need to do is we need to assign one variable the X's, and for us I'm going to assign these, the D variables, the X's, and then we're going to assign the Y variable, the weight variables, the Y. And so that means for this, for example, this one right here, 750, I'm going to come over to 7 on my X, and up to 250 on my Y, and I'm just going to put a dot there. So I'm going to do this for every single one of my points, and it'll be easier if I did make a nice axis to use. So let's grab our axis, and you'll notice a few things. You notice I put a little zigzag. That's because there's a big gap. I think if we'd included all the numbers, we wouldn't be able to see any difference. But here's my 7 to 28, and let's just go put each of those dots on there. So we've got 0, 252, so that's a dot that goes somewhere like right here. 5 and 249, so that's somewhere like right there. 7 and 250, so that's somewhere like right there. 12 and 247, 12, 247. 19 and 246, so that didn't change much. And then 28 and 244. And so what we see is that this person had a diet, and their diet has overall caused their weight to decrease over time, which is good. You would hope that a diet would cause your weight to decrease, unless, of course, you're trying to gain weight, which I know a lot of people, especially athletes, people are trying to achieve some sort of fitness goal, maybe trying to gain muscle weight. But usually diets are helping us lose weight. And so this is the idea of a scatter plot. Now, once we have a scatter plot, the next thing we want to do is we want to fit a regression line. And what a regression line is it's a line that's just cutting right through the middle of the dots. And the regression line is this line that just comes right here and just fits right through the middle of these dots. And so we try to fit this line as perfectly as possible. Well, what is the best line? Notice there are lots of lines that go through the middle of the dots. How do we decide what the best one is? Well, what you do is you take each distance. So there's a distance, there's a distance, there's a distance, there's a distance, and there's a distance. You take each of those distances and you try to make the sum of all those distances as small as possible. Well, actually, we don't make the sum of the distances as small as possible. We make the sum of the squares of the distances as small as possible. Why do we use squares? Well, it's kind of some of the same argument as for why we squared everything when we did standard deviation, or why we squared everything at other points this semester. Part of it is to make all these distances positive, because we don't want negative and positive distances canceling out. But another part has to do kind of like with the connection to Pythagorean theorem, which makes mathematics really nice. And so we know Pythagorean theorem has a relationship between a squared and b squared. Well, it actually happens with a lot more squareds as well. So there's kind of this idea going on. The good news for you is you don't have to do any of this, because we're going to learn how to have our computer do it for us, and our computer will spit out the answer for us. So good news for you on that. Okay, now, but this is what we call the least squares that does all these squares right here. Okay, so once you find this equation, we're gonna try to use it to solve different things. So what is this equation going to tell us? Well, first, this equation, which we'll come up with in just a little bit, my next video, I'll share with you how to do this in Excel or other programs. Well, this equation happens to be the equation y equals 251.24 minus 0.27x. So this is kind of a decent approximation for that regression line. what is this line telling us? Well, what you'll notice is there are two parts to the line. The first part is this, and the second part is this. Notice this is the slope of the line. And if you remember back from algebra class, slope just tells us how steeply the line goes down. And so that means if you go over 1 unit, so let's draw that right here. If you go over 1 unit, what that means is that you went down 2.7 units because it's negative. So that means over 1 and down 2.27 units. That gives you some picture of how much weight you're losing each day. So each day you're losing about 1/4 of a pound, which is a pretty good result if you're on a diet. Secondly, what does this number tell us? This is what we call the y-intercept. And that is the value right here where you hit the axis. The y-intercept kind of tells you your starting weight. So whenever you do your whenever you do your linear regression, you always have two numbers. One of the numbers will tell you your slope, and that's how quickly your values are changing. And the second will tell you your y-intercept, and that's the point where you hit over here. Okay, once we have this linear regression, we're able to do different things with it. So let's go and let me write this regression down one more time, and then we'll talk about some problems that we can do. So we'll go through exercise 11.2. Okay. So what was our equation? Y equals 251.24 minus 0.27x. And so when we get to this problem, we're going to want to answer a whole bunch of questions about this. So question A was just find the equation. So there it is right there. And again, that's A is going to be coming up in the next video. On part B, you're going to say, well, what would you expect a person to weigh 14 days in? Well, we can already see by looking at our picture what we'd expect. And so if you look at your picture, we go, oh, okay, 14 is right here. And so that means we would expect somewhere between, 246, 247, somewhere around there. Seems like a pretty reasonable guess. Well, one way you can do it is guess, but the better way to do it is to actually take that number and put it in your equation. So you just use x equal to 14 in the equation, and that gives us y equals 251.24 minus 0.27 times 14. And so we just calculate that out. 0.24 minus 0.27 times 14. And I got 247.46. And so that's our estimate for what their weight will be. 14 days into the diet. Yeah, that's pretty close to what we guessed it would be. Okay. Part C is how much would we expect this diet to help them lose per day, and we already talked about this. That is your slope. That's the slope in your equation. It's the part that's attached to the x, and that means they're going to lose 0.27 pounds per day. Approximately. You'll notice that it depends on the day because there's a little bit of error and a little bit of give. But let's come over and talk finally about part D. And part D says, well, what would happen 100 days into the program? Well, that's simple. We take 100 and put it in and see what we get. So y equals 251.24 minus 0.27 times 100. I forgot to close my parentheses over here. And let's type that in and see what I get. And what I got was 224.24. Now, one thing I would like you to do real quick, now that we're done, is just take a second before I answer the question. Which answer do you think is more accurate? The answer that came 14 days into your diet, or the time that came 100 days into your diet? Which weight would you be more confident in giving your answer for? Okay, so think about that. Hopefully, as you thought about it, the answer is this 14 days. And the reason is if you look at our data, where is 14 at? 14 is right here in the middle of all the values we've already accepted. And so 14 is in the middle of our data. And so therefore 14, it seems like we're pretty sure they're going to be around 247, 246, somewhere in that range. So we're pretty close. Where is 100 at on this picture? Well, 100 is 100. 100, well, we have to go way over this way to get to 100. Who knows what's going on by the time you get to 100? you're making a lot of really big assumptions. The biggest assumption is that you keep losing weight at the same rate for the next 100 days. And anybody who's tried to diet, you tend to know that you tend to lose more weight at the beginning, and then at some point you start to level off a little bit. And in fact, we know that it would be ridiculous to use this number forever, because what if I gave you a part that says how much would you weigh 1,000 days after you were on the diet? Well, if I asked you for 1,000 days, you would come up with an answer that is negative 18.76. So all of a sudden, 1,000 days later, you weigh negative pounds. Well, what does that mean? I guess that means you died and your body turned into gas or something. This is ridiculous, right? So of course your weight doesn't continue like this forever. This is a difference that we call the difference between extrapolation and interpolation. So we have two words that we're going to use. The first word is the word interpolation. And interpolation, you can see the word inter, right here. And so inter usually means inside of. And so interpolation is an estimate taken inside the data you've already collected. An estimate within the range of your gathered data. However, that should be compared to extrapolation. And when you look at extrapolation, what you see is the word extra in here. And extra usually means you're going beyond or you're doing something extra. And an extrapolation is an estimate outside your gathered data. Extrapolation should be used with caution. So this is the common thing where you'll see extrapolation used all the time if you kind of watch the news or watch TV or anything, and you frequently see people using extrapolation where they're trying to make estimates outside of the range of data to guess what's going to happen in the future. And the truth is that those estimates aren't worthless, but they should always be you should always be really cautious with them, because you're making a big assumption, and the assumption is that the trend that happened during your data will continue forever. And that, as we know, is not always a safe trend. Okay, so that's the biggest difference between interpolation and extrapolation. By the way, whenever you go watch like news stories or something, you see this all the time. You see someone say, well, this has happened in the last 2 years, so that means 50 years from now, this is going to be the case. And you go, well, is there any reason to believe this trend that's happened over the last 2 years will continue for the next 50 years? And the answer is probably not. Probably the trend's going to change at some point. The final point that I'm going to make is that of correlation versus causation. And correlation versus causation is a really big point to be made in the world of statistics. And that is, just because two things are connected to each other, just because your lines fit your dots well, doesn't mean that one set of numbers is causing the other set of numbers. In this case, we probably think that the diet is affecting their weight, but it could be that they also started an exercise program, and maybe this diet is just eating Twinkies every day. And maybe the diet is not what's helping, but they've started a new exercise program, and that's really what's making all the difference. So there could be other variables underneath the surface. It's a human thing to decide whether these things are causing each other, not whether it's a mathematics thing to decide whether they're correlated. Maybe, I don't know, maybe they got a tapeworm and that's why they're losing weight. Okay, that's a little bit gross. Okay, with that being said, I'm gonna go ahead and jump ahead to the next set of videos, and what you're gonna see coming up are two videos. And so I'm gonna have video one. Video one is going to be using Excel. So I'm going to teach you how to do all this. I'm going to teach you how to find this equation using Excel. We're also going to find another important number called R, and we'll talk about what R is in the last video in the series. Finally, video two is going to be on numbers, which that's for those of you who might be using some sort of iPad or mobile device to do your calculation. The problem is Excel works perfect, but if you have Excel on your mobile device, sometimes they don't have the same features than Excel on a laptop or a desk computer does. So if that's the case, if you're using like an iPhone or an iPad, you can use numbers and that'll work just fine. Finally, I'm also going to put a link to a video that I made for my other calculus class, which has what to do if you have a TI 84, 83, 84 type calculator. So if you'd rather use a TI calculator, I'll put a link and you can click on that, and that'll take you and teach you how to do it with one of those devices. Okay, so let me be done now, and then go pick the appropriate one depending on the type of device you're using, and hopefully that helps. If none of these, if you don't have access to any sort of device like this, talk to me. I have other ideas, but I'm hoping that everyone has access to one of these options. The vast majority of you will be able to use Excel. All right, I'll see you in the next video.